Welcome back. Welcome back, Flare community. Hope you're all well and having an incredible day. Happy Wednesday. We don't normally stream on Wednesday, but today is a special occasion. If we jump over here to Twitter, we have a live demo that's about to go down in less than 5 minutes, actually. And this isn't a demo of, I guess a demonstration of the state connector. And, you know, basically what's going to happen is there's going to be NFTs that are going to be bought on the Flare network, but using tokens from a different network. And these are going to be from the XRP ledger and the Dogecoin network as well, right? So basically what's going to happen is the state connector is going to observe these transactions. And then once they've been verified, they're going to initiate a transaction on the Flare side of things. And I'm particularly excited about this, and we was talking about this quite in depth in the Patreon chat yesterday, that this is an opportunity for the Flare team to really highlight something that is novel and very unique to the Flare network. You know, we talk about blockchains all the time, and a lot of them are very generic. You know, you've got EVM compatibility, you've got something that's fast, you've got something that's scalable, and something that's very cheap. And don't get me wrong, these are fabulous foundational attributes to have within a network. But what Flare are doing is something much more than that. The state connector and the on-chain oracle, the FTSO, these are all things that are unique to the Flare network. And I think this is what's really going to drive the adoption and the interest within the network by highlighting some of this novel functionality. And the state connector, this is the first time that we're really going to see the power of it. So we've got 2 minutes to go. And yeah, this is what's going to happen. As I said before, in fact, I've got another tweet here. And yes, you can see that they're going to be using Dogecoin and XRP. So Hugo's going to be presenting this, and also Philip as well. He's a senior Solidity developer. We all know Hugo, the CEO and co-founder, and it's going to be happening in just a couple of minutes. And by the way, when this does start, if you are having any problems hearing the audio, please let me know in chat regarding to the audio that's coming from this demonstration. And I'll certainly be able to fine tune it, you know, if you want it a little bit louder or something like that. Something interesting to note here is that there was this tweet from Hugo, a sneak peek of the demo tomorrow. You've got the Flare and the Expector logo here, and this looks like an agent from the Expector world, and this is pretty interesting to me. We do know that Dirk over here, he had a meeting with Hugo just a couple of weeks ago, I think last week, and Expector is a very interesting project, you know, building a metaverse, predominantly focused on the XRP ledger now, but they do have ambitions to expand to other networks too. So I guess what we'll do is we'll quickly check out this. I mean, it is time right now. I don't want to miss this. Here we go. So let's jump in and we'll give it a listen. If you are having any difficulties hearing, please do let me know.
Called a smart contract trigger. This is where an action on one chain triggers something on Flare, or in today's demo on Songbird. Before we get there, and for those that are new to Flare, I'll briefly run through what has been built with Flare and why we think it presents a compelling addition to the blockchain space. So what is Flare? Flare is a purpose-built blockchain aiming to solve some of the biggest challenges that we believe are really constraining the adoption of the industry. It's been engineered to have high performance as a decentralized cross-chain platform that delivers a set of native and open protocols secured directly by the network. These protocols serve as the foundation for developers to build interoperable and composable applications across chains. Interoperable not only across Web3, but between Web 2 and Web 3. This means applications are able to be interoperable across many networks and composable with other applications on Flare. In essence, Flare is built to help the blockchain industry scale, acquire more users, and make blockchain substantially better by enabling digital assets and on-chain information to flow freely across all the different blockchains. So what is Flare as a layer one? So Flare is a layer one. So it's like other blockchains, Ethereum, Cosmos, Avalanche, Bitcoin, XRP, etc. It integrates the Ethereum virtual machine. This is essentially the system that powers smart contracts on Ethereum, but it also powers smart contracts on Flare. The Ethereum virtual machine is used by the majority of developers in the space, but of course, Flare can change that virtual machine through governance should an alternative virtual machine come along that is superior. But unlike other layer ones, Flare has two important core native protocols. The first is called the Flare Time Series Oracle. This protocol delivers highly decentralized time series data to applications on Flare. Currently, this includes digital asset prices, but it could include any other form of time series data, such as financial prices, non-crypto financial prices, weather data, carbon emissions data, indice data, anything that moves over time. The second protocol is something we call the state connector. The state connector allows Flare to acquire information from other blockchains and the internet in a secure and decentralized manner. This data, once acquired on Flare, can then be used securely and scalably, and most importantly, trustlessly, with smart contracts that are operating on Flare. So let's dig in a little bit to the Flare Time Series Oracle. The Flare Time Series Oracle is a highly decentralized protocol for safely retrieving external time series data onto the blockchain, in this case, Songbird and Flare. It's cryptocurrency pairs right now, but it can be financial data, for instance, FX rates, or, as I said, things like carbon emissions data, essentially any time series data. Currently takes data at about a 3-minute interval because that's what's required for the network today, but this can be reduced substantially. Currently, we have about 90 providers of data, so what we call independent FTSOs, both on Songbird and on Flare. But again, this set can potentially be expanded very substantially. These data providers are incentivized to deliver accurate information. They're incentivized by the system to do that. So let's just dig in a tiny bit more. Independent entities called data providers fetch price pair data from, at the moment, crypto exchanges. Both Flare and Songbird currently have more than 90 independent data providers. They then submit this data to the FTSO contract. This data is then processed by that contract to give a single estimate from multiple estimates that are incoming. Price data is computed and then made available on the chain to any application. And most importantly, any application can take any one of the price estimates as their desired price. So moving on quickly to the state connector. State connector is the second of Flare's two native core protocols. State connector allows deterministic and immutable data from other blockchains to be securely acquired by applications on Flare. This means applications can use data from other blockchains directly on Flare in their smart contract. Furthermore, a specific setting of the state connector allows for data from what we call single source of truth APIs. So any API, essentially, this is the majority of the internet, to be conveyed to Flare for use with smart contracts. This makes it extremely flexible and easy for the system to be extended such that developers can have access to the greatest set of data possible. This allows Flare not only to get data from other blockchains, incredibly important, but also to get data from the internet. So to dig in a tiny bit more on the state connector, State Connector uses a set of independent attestation providers to acquire specific information from these external systems that is requested to be used on Flare. State Connector smart contract then verifies that a suitable level of consensus over this data has been reached across these attestation providers. Once approved, the data is securely reported to the network and available for use in applications on Flare. So in a second, we're going to start the demo, the exciting bit, the fun bit today. And today's demo will be purchasing NFTs on Songbird, Flare's Canary Net, directly with tokens on other blockchains. We'll be purchasing an Expectar NFT on Songbird with XRP and a DOGE NFT on Songbird with DOGE. We'll be pricing the NFTs using the FTSO system. So I'd like to bring up Philip Koprivec, our senior Solidity engineer, who will be running the demo. We'll demonstrate how the FTSO and the State Connector can be used to trustlessly purchase an NFT on Flare, but in today's case, Songbird, using the token of a different chain. In this case, DOGE and XRP. Hey, Philip, how are you?
Hello, how? I'm good. Thanks.
Thanks a lot. I'm going to go away now and let you do your thing.
Okay, thank you, Hugo. Thanks for the introduction. Thanks for a short introduction to the protocols. And yeah, let's dive in the demo. So I'm Philip, and today we'll see how we can bridge external information from external chains directly to the Flare ecosystem and see what we can do with this. So we're going to mint an NFT on Flare ecosystem, specifically on Songbird chain. Songbird is Flare's canary network. And we're going to do this by paying on external chain and using the State Connector to prove that those payments really happened. And most importantly, proving this in a decentralized way without trusting any specific oracle for this bridging. So let's take a quick walkthrough. So we're going to be bridging information from external chains to Flare and Songbird. And to do this, we're going to be using the NFT demo app that is currently live on Songbird. And the first thing we're going to do, we're going to open the dApp. We're going to select the preferred token in which we want to pay. And the dApp is going to query the FTSO system. And the FTSO system will respond with a specific price so that we can price the NFT in Doge on the XRP ledger without having to rely on some oracle to provide us this price. And once we know this, we can reserve our NFT. This is essentially just a contract call on the Songbird network to reserve, to make a reservation and get some additional data. And our contract, the NFT contract, will respond with the data that we require to proceed with the payment. So the amount we need to pay, the payment address, and the reference we should include so that we can identify the payment with a specific NFT. And once we make this payment, importantly, we make this payment outside of the Flare ecosystem. We make this payment on an external chain, and the State Connector is able to attest to this. And once we do it, we essentially have to gather all the information about our data. We need to wait for the payment to complete an external blockchain. So for the external blockchain to confirm it, we then provide this data via our local attestation client to the State Connector, and the State Connector starts the proving route. So the State Connector emits an event, and now the default set of attestation clients, so this decentralized set that is proving things, then starts to request the things, gets the information, and then after specific intervals, pushes this directly to the chain and thus confirms that this specific transaction, or more generally a specific batch of transaction, really happened. Once this is done, we essentially just supply the information about the transaction on external chain to our NFT contract on Songbird. And this contract firstly checks that this transaction information we supply to the contract is correct. So we paid the correct amount, the correct address, and then uses the State Connector to assert that this transaction really was confirmed by a decentralized set of attestation providers. So an important thing to stress here is the fact that all core operations during this data flow are essentially decentralized. So we are never relying on a specific data provider. We're never relying on a specific oracle, but the State Connector and the FTSO system that are native to the Flare essentially rely on a set of providers to achieve a conclusion on what exactly happened. Okay, so let's see it in action. So we're going to mint this on Songbird. We're going to be using this demo dApp that is deployed there, and we can just start. So the first thing we need to do, this is a simple demo dApp. We need to connect our wallet. So as Hugo already said, Flare is an EVM compatible wallet. So any EVM compatible wallet would do. So you can use MetaMask, you can use anything, but in our case, we're going to use Bifrost wallet that natively supports Flare, and we're going to use the wallet connect to do this. So the first thing we need to do, we pick a currency, let's say DOGE, and immediately the DApp queries the FTSO system, calculates the price, and this is a specific price for our NFT. And the last few digits are used to, once again, some sort of as a memo field to identify our NFT with the transaction we're making. So we make a reservation. Reservation is essentially just calling a contract to confirm that we want this NFT to be minted. We sign the transaction, we confirm it, and immediately after the transaction is signed, our NFT contract gives us back information about the payment we need to do. So the destination address we need to pay to, the reference we should include, and the amount that needs to be paid. Once again, the amount is calculated using the FTSO system. So the QR code is generated here, and we use any compatible wallet that can be used to make this payment. So we scan it, we check that the payment is correct, and we send. Okay, we pay, we sign the transaction, and away we go. So the payment is now done. So the Flare part is now done, and we've already paid everything else on the external chain. So we've moved the value on external chain, and now we need to transfer this to Flare. So the important thing to notice here is that the state connector is secure by default. So we never want to include the transaction that was not really confirmed on the network in the state connector, because that would be problematic from a security standpoint. So for our case, we'll need to wait quite a while to get this transaction confirmed. We're just going to use a transaction that we're sure has been confirmed on the DOGE network. Apply it here, create a request. And now what we're doing now, we're essentially prepping our local attestation provider to get us all the data about the transaction, push this to the state connector, and prove it there. We create a request. This request is again an attestation, a request on Flare. And now we request an attestation from the state connector. So what we're doing, we're essentially querying the state connector saying, prove that this is the hash of this specific transaction sorted with some Flare specific data, and that it did happen on the Dogecoin network. We confirm this, we sign this transaction. And once the transaction is signed and confirmed by the network, the state connector kicks into action. So all the attestation clients in the default suite, the full set of decentralized attestation clients, has now received an event that this transaction should be proved in this specific attestation round, and they're now confirming it, they're now querying their own nodes to confirm it. So we need to wait for a while, and while we wait for the state connector to bridge this to Flare, let's just hop in on another version of this DApp and continue our purchase, but this time do it on the XRP network. So while we're waiting for the state connector to confirm the DOGE part, we're just going to buy another NFT on the XRP ledger. So again, we select the currency, and before doing anything, we should connect our wallet. Again, wallet connect, scan the QR code, connect to the network, and select XRP. So the price is different in XRP, but again, it's calculated using the FTSO system. So again, we're buying the NFT number 2, and we should pay at least 2.5 XRP on the XRP ledger. Again, we're going to reserve the token. Again, we're reserving token for the XRP, confirm, sign the transaction. And after the transaction is signed, the contract gives us back the things we need to prove. So we should send to this destination. The destination is obviously different because we're paying on a different chain with this reference and this specific amount. In this case, we don't even have to transfer to a new net. We're going to allow the Bifrost to connect directly to our DApp and make the transaction on the XRP ledger directly from the DApp. So again, query the XRP ledger, we're sending this transaction with this memo data to this address, confirm that it's correct, sign it, payment is sent, and now again, as before, the payment is sent on the XRP ledger, and the only thing we need to do now is to prove that this transaction from the XRP ledger really happened and get this to the state connector. So what do? The transaction ID is automatically returned from the Bifrost wallet. We again create a request. We should attest that transaction like this happened. And again, we request an attestation from the state connector on Songbird. So again, we're saying, okay, we want you to prove this transaction and make it available to the network. We check that everything is correct. We confirm it. We sign it. And transaction is submitted. And now it's all in the hands of the state connector to collect this, choose it, commit it, reveal it, and finalize it. Now, if everything went smoothly, so we're back on the DOGE part. So the DOGE part has been paid, and we're waiting for it to be confirmed. So the state connector essentially works in rounds. So we're collecting the information we need to prove. We're choosing and committing the Merkle route referring to those transactions. Then the state connector at the station providers reveal this, and then they finally just finalize everything, that everything went smoothly. Although the NFTs we bought here were not that expensive, the state connector, through a decentralization and not having a stake in the system, is able to provide a secure and safe and decentralized information about transaction happening somewhere else for a transaction of a practically arbitrary value. So we're not limited by the stake in the state connector system. Okay, so let's check. We can already get a proof from our local attestation provider. And this is the proof that is essentially identifying our transaction and transferring this to our contract. So what is this proof? This is the proof that was generated by our attestation client and also submitted to the state connector. And essentially, it contains the full information about the transaction we did. So in which round was it confirmed, the hash of the transaction, attestation types, and most importantly, it contains the full information about the transaction. Why is this important? Because we're going to be putting this again back to our NFT contract, and the NFT contract can then check if this transaction confirms to the transaction that should be made to make a payment. So is the value high enough? Was the timing correct? Is the chain correct? Is there a correct memo field? And is the receiver's address correct? Okay, so the state connector has finalized. This is the proof we're sending to the contract. And it's now time to essentially query our contract one more time, this time with all the information about the transaction. So essentially, we're sending all the information, and the contract, which is just a simple program, can then send it. Okay, we confirm this, we sign it, and after the transaction is confirmed, bam, the NFT is minted. So the contract received the correct information. It checked that the transaction was coherent with the rules it set, and it also checked with the state connector that this transaction really was included in the proof made by the state connector. So this is our brand new NFT. We can also see it on Blockchain Explorer. And we can also take a look at our wallet when we can see that we have acquired a new multi-chain minted NFT. Okay, so the DOGE part is done. And the only thing we need to do now is to return to the minting phase of the XRP ledger and also finish the transaction there. So the state connector has almost finished here. And again, we're going to do the same thing as with the Dogecoin. So we're going to get proof that uniquely identifies our transaction. So again, here we have a proof. Here's the round ID, it was included, the message integrity code, everything that the smart contract needs. So the important thing is this data is directly sent to the smart contract, which is just a program and can do any computation it wants. In our case, we're minting an NFT, but the possibilities are practically unlimited. We can execute a swap, we can liquidate something, we can move some funds, we can execute a time-locked contract call, we can claim things, We can even communicate with other blockchains through other bridges. Practically, the options are limited. The only thing that is important is the fact that information about this transaction having been done on an external network has been transferred in a decentralized way. So there are no steps during this minting process, during this execution process, during the trigger process, where we rely on a specific centralized entity to provide us with correct data, with up-to-date data, or at least provide us with some data. So we're always just kind of using the data, as it were, without having to worry about the penalization processes and stuff like this. Okay, so we just wait for a few seconds. And again, so we're sending this data directly to our NFT contract. And the only thing we need to do is to confirm this, sign the transaction, and once the transaction is done, our X-Spectre NFT is minted. So again, EVM compatible chain, all the computations can be done. And let's also see that one in Explorer. And yes, here it is. Let's see, we should also be able to see it in our wallet. And yes, we're the proud owner of a new NFT minted on Songbird using the power of decentralized information bridging by the state connector. And let's just check all the owners. And since I've minted with two different wallets, we can see that we have two different owners. The first one owning a DOGE NFT and the second one owning an NFT paid by on the XRP chain. So that's it for the demo. I'm going to return back to Hugo, and thank you.
Thank you, Philip. That was awesome. So today you saw an example of what we call a smart contract trigger. This is where a smart contract on Songbird or Flare is triggered by an action that happens elsewhere. In this case, the payment of DOGE on the DOGE chain and XRP on the XRP ledger. We bought NFTs on Songbird directly with XRP and with DOGE. We did this in a trustless and decentralized manner. This is possible to do on Songbird today. There were quite a few steps. In reality, the bulk of this workflow would be integrated into a front-end product like an NFT marketplace or a wallet, such that the user only needs to do one or two transactions to buy an NFT on Flare with a token from any connected network. We look forward to helping developers build out around this functionality. We think it's really cool and very powerful. Thank you for joining today's demo, where we showed you a simple but powerful process native to Flare's core functionality. Thank you. Have a good day.
Wow. So there we have it. We are officially on the cutting edge of development in terms of functionality that's coming to Songbird and Flare. And I'm really actually glad that they did this on Songbird. You know, Songbird is the proving ground, let's say, for all developments that really are going to be migrated onto Flare in the future. Yeah, so sorry, I just saw that Carrie in the comments is talking about subtitles. You can't actually add subtitles. Sorry, Chris, too. You can't actually add subtitles to something live, but if you watch this on the replay, YouTube automatically adds in the subtitles, so you should be able to watch it once again. But yeah, very interesting indeed. And you know, we can see the power of the state connector. I think this is a revolutionary concept, and it just goes to show that we are right in the right place at the right time. You know, no one else is really doing this, and all of this workflow was done in a decentralized manner, meaning that there was no centralized entity that the network was relying on. Again, you know, we can do this with XRP and Dogecoin, and as Hugo said, the state connector is already live on Songbird. And that means that anyone can essentially build out this functionality to allow people to use other assets from different chains to purchase NFTs. I'm really looking forward to it. I guess we're just going to have to wait to see how this evolves over time. I'm probably going to do a couple of videos about this stream in particular to sort of break it down a little bit further. But that was the demo. What do you guys think in the comments? I'm actually in the process currently of buying one of these NFTs myself on the XRP ledger. I mean, if we can go back over here, see if anyone else has the same idea. Just 2 minted at the minute. I mean, the process, as they said, you know, it is quite like a lot of steps right now. But Hugo was saying that in the future, it's going to be a case of the application integrating all of this functionality that sort of doesn't make it so complicated. Even though it's not really that complicated, you just sort of go through the motions. But yeah, I'm pretty excited. Give me a second. Please look at the... Yeah, so, yeah, I think you guys get the idea. Incredible work over here at the Flare Network. Atata Inu, yeah, it might be complicated. You know, you do have to click some buttons, and I think the full process takes about 2 minutes at the minute. But as Hugo was saying, this functionality is actually going to be added into the application. So you might not have to do 9 steps. You might just have to do 3 steps. So it is going to be simplified. They just did this to show the full process. Okay, so yeah, I think it's a step in the right direction. And they're definitely making way in terms of the tagline over here that you can see of connect everything. So that's pretty much the video, guys. I really hope you enjoyed it. I certainly did. And as I said, I'm going to be breaking this down in the future. But that's pretty much it. Tomorrow we've got the live stream with the Flare Community Poker Club draw, and also the community chat on Discord for those who are interested. You can join the Discord. There is a link in the description of this video. So yeah, please feel free to do so. And thanks a lot for watching. And until next time, I'm out.
We have liftoff.